Welcome back, everybody. I've got two more examples to do regarding AND problems, and so we are going to do these with the standard deck of cards. So the problem says two cards. Now I want to stop there. That is the key to these AND problems, that you're dealing with two or more events happening. This is not the same as the AND from section 11.1, where it was the probability of two things happening at the same time in one draw. So I'm drawing two cards, and I'm going to select them from the standard deck of playing cards. So the first thing I want to do is I want to find the probability of a picture card and a 5. Now, this AND, because it's two or more events, has the implication of and then. So there is an order to these events. And so when you're doing AND problems of drawing these cards, I'm given a little additional information. The first time I do this problem, I'm going to do it with replacement. And what with replacement means is that after I draw the first card, I'm going to put it back in the deck before I draw the second card. When we do this problem a second time, we're going to do it without replacement. And without replacement means that once I draw the card, it stays out of the deck. So just want to make you aware of that. So now let's go ahead and do these problems. So I'm going to find the probability of a picture card and then a 5. So going to my standard deck of cards, remember there are 12 picture cards. And then there are 4 5s out of my 52. So I go back, and so when I do this problem of the picture card and a 5, the probability of a picture card is 12 out of 52. Then I am replacing that card back into the deck, and the next time I draw is I'm drawing a 5, and there's 4 chances of getting a 5. And because I replaced the first card, there are still 52 cards in the deck. So I need to multiply these two fractions together. So I'm going to reduce 12 out of 52. 4 goes into 12 3 times, and 4 goes into 52 13 times. And then 4 out of 52, 4 goes into 4 1 time, and 4 goes into 52 13 times. And so I end up with, when I multiply straight across, 3 out of 169 times. Now I'm going to do that same problem without replacement. So I draw the first card, and I draw my picture card, and there are 12 picture cards out of the 52 cards. That does not change from the first problem. Here's what does change. Whatever card I have just chosen, I am not putting back in the deck. So now when I find the probability of a 5, there are still 4 5s in the deck, but now there are only 51 cards. So the probability has changed. So when I now multiply these fractions, 12 out of 52 reduces to 3 over 13. 4 out of 51 stays 4 out of 51. And I end up with 12 over, I need to multiply 13 times 51, and that turns out to be 663. And I can do just a little bit more reducing on that. 3 goes into 12 4 times, and 3 goes into 663 221 times. Now notice, in this first problem, my probability of selecting a 5 did not change over what I would expect drawing a 5 out of the deck of cards. When two events happen and the probability of the second event is not affected by the first event happening, those are called independent events. In this second problem, when the probability of the first event happening changes the probability of the second event, these are called dependent events. So we're going to do another example. We're going to do the same thing with the second problem, the probability of getting 2 hearts from my deck of cards. And so Here we go with that. So what's the probability of getting 2 hearts if I do this with replacement? So the probability of 2 hearts means the probability of a heart. I'm going to try to draw a heart, and then another heart. And so I go back to my deck of cards, and I'm going to make this look a little prettier. So I'm going to get rid of my old circles. And I see, I'm counting as I'm erasing here. I see that there are 13 hearts in my deck of cards. And here they are, my 13 hearts. So I go back. And so with replacement, the probability the first card is a heart is 13 out of 52. Times the probability the second card is a heart is 13 out of 52. Both of those 13 out of 52s reduce to 1 over 4, and so the probability that I get 2 hearts when I replace the cards is that'll happen 1 time out of 16 times. I can do the same thing now without replacement, and remember that without replacement means that I am not putting the first card back when I draw the second. So the first heart is still 13 out of 52. That does not change. But now the second one, if I've not put the first card back and the first card was a heart, then that means there are only 12 hearts left in the deck out of the 51 cards that are left in the deck. So that probability changed. So 13 out of 52 reduces to 1 out of 4. 12 out of 51, 3 goes into 12 4 times. 3 goes into 51 17 times. And I notice that these 4s are going to cancel now. And so that happens 1 out of every 17 times. So the probability changes. So that is the difference between an independent and a dependent event. Good luck with your homework. Hope to hear from you soon.